Welcome back to practice questions. We are discussing differentiability in various functions, and we're down to question number 22, page 112, and this time we'll continue with question C. So in this question, we have to determine whether or not the function is differentiable at x equals 1, and we'll look at both algebraic and graphical solution. So in order to determine whether the function is differentiable at a specific point, we first determine the derivative at any point. So first, let's write the equation of the function, and since we have radicals involved in this equation, we'll convert them to powers. So we have x minus 2 squared. And then this radical here will become a power. And the power is in rational form, 1 over 3. That's where the radical comes from the fraction in the exponent. So let's simplify this a bit, because why not? So again, we haven't differentiated yet. We are just preparing our function for differentiation, which means that we're trying to write it in the most simplified form possible, which will make the differentiation easier. So now we can start differentiating this function, and we'll say that the derivative of h would be equal to, notice that here we have the power rule with a little bit of a chain. So that means we have 2 over 3. We have x minus 2 to the power of 2 over 3, take away 1, and then the derivative of the inside. Now, luckily here, the derivative of the inside would be derivative of x, which is 1, minus derivative of 2, which is 0. So 1 minus 0 is practically 1, and the multiplication by 1 won't really change the expression. So, and that's the reason I said luckily it is equal to 1, because even if you forgot actually to differentiate the inside, it still wouldn't change the answer, but you shouldn't forget this, just in case. So let's take a look, and let's check what the derivative expression looks like. So we have 2 over 3. We have x minus 2 to the power of, so notice here you have 2 over 3 minus 1, so minus 3 over 3 will give the exponent of negative 1 over 3. So let's make that exponent positive so we can have a better idea of the character of this expression. So x minus 2 to the power of 1 over 3. Now, as you can see, this would be the most simplified form of the derivative with all positive exponents. And now we have to see, is the function differentiable? And if not differentiable, is it non-differentiable for any real number x or at specific points? Now, to be differentiable means to be evaluatable or to exist for any real number x. And as you can see, there are restricted values for this equation. And the restricted values are hiding in the denominator. We know that the denominator cannot equal 0. So let's check and see what we have in the denominator so that we can make a decision as of what can make it 0. So we have 2 factors in the denominator. The number 3, which is a constant number, that won't change, that won't make the denominator 0 ever. And then we have x minus 2. Now here we have a variable, and depending on what this variable may decide to become, then this entire factor can become 0. So we're going to say, okay, so x minus 2, it can be 0. We don't want it to be 0, so we have to say it should be different than 0, and x should be different than 2. So we're going to say that at x equals 2, the derivative h prime of 2 doesn't exist. So this would be the point where the function is non-differentiable. So at x equals 2, the function is non-differentiable. Now the question is specifically asking for x equals 1. So it's asking if the function is differentiable at x equals 1. And if you substitute x by 1, then we'll get 2 divided by 3 times 1 minus 2 to the power of 1 over 3. So that would be 2 over 3 1 minus 2 is negative 1 to the power 1 over 3. Now, be very careful in here. The exponent will have an odd denominator, which means that the number inside, the number in the base, can be either positive or negative, which means that this is actually definable and it's equal to 3 times negative 1, so that's negative 2 over 3. So we'll say that at x equals 1, this function is differentiable. So, but it's not differentiable at x equals 2 as we discussed. Let's take a look and see what the graph of this function looks like. So in this case, we had y equals the third root, or we should say x minus 2 to the power of 2 over 3. So I'll keep the power here in brackets just to be sure. So as you can see, this function is non-differentiable at 2 because it presents a cusp, which means that the tangent line will be vertical. And at x equals 1, you see that you can draw a tangent perfectly well, and that means that the function is differentiable at 1. And thank you for watching again, and bye for now.